So our learning goal today states, I can solve an equation in 2 or more, so 2, 3, 4, however many they want to have in it, variables for one of the variables. Well, we've been solving equations for a variable, but there's only been one variable. There's no choice which variable to solve for because there's one involved in it. But now we're going to take the equation and we're going to have to, because it would be more than one variable in it, we're going to have to solve it for the one they wanted to solve for. And our answers aren't even going to look close to something like x equals 3 or y equals -4. They're going to be answers with a whole bunch of variables still in them. Okay? So we're going to have to use the steps that we've learned, and we're going to have to think kind of abstractly. We're going to have to be like, oh, this doesn't make sense, but I'm following the process that I'm supposed to, so hopefully this is going to turn out all right. So in your book, somebody tell me what's the first vocab lesson, or word, excuse me, not lesson, first vocabulary word in this lesson, formula. What's a formula? Somebody want to offer a hand here to read it for me? Okay, go ahead, Connor, what is it? What's a formula?
A formula is an equation that states a rule or a relationship among quantities.
Quantity. Okay. It's a rule stating a relationship between quantities. So can somebody give me an example of a formula? Do you know any formulas? Have you come to me with any formulas? Oh yeah, lots of them. You've worked with a lot of formulas before you got to algebra class. Okay, think of one. How do you find the area of a rectangle? Oh, so capital A equals length, little l, times width, little w. That's a formula. Capital A equals LW. That's a formula. It's the formula for finding, it's the rule for finding the area of a rectangle. You know how to find the area of a triangle. A equals 1/2 base times height. Circle, I think that's where we can include pi. Area of a circle is pi r squared. You know a bunch of formulas already, even though you don't seem to be able to spit them out. You have worked with, if nothing else, a bunch of formulas already up to this point. So some of the equations we're going to be working with in this lesson are formulas. They're rules for finding a specific thing. Others are just going to be equations that have a bunch of variables in them, and we just got to know how to rearrange them. That's really what's going to happen here. When you're done solving, all you've really done is rearrange the equation. You've renamed it. It just has a different look. It has a different look than what it had before. So let's just do some kind of like exploring here on this front side. What do you think that's the relationship for, or the rule for? What formula is this? P equals 2L plus 2W. Perimeter. Perimeter. Perimeter of what? A rectangle. Yeah, this is the perimeter of a rectangle. Because perimeter means what? Distance around. Well, a rectangle has 2 lengths that are the same, right? Same length. And 2 widths that are the same. So we could shortcut it instead of saying L plus L plus W, we could say 2L plus 2W, right? So that's a formula. Now, I want you to hear me really loud and clear on this, because if you start changing the case of the letter from uppercase to lowercase, vice versa, lowercase to uppercase, keep the case that the letter is given to you in. So P is given as a capital P, because it stands for perimeter, the big guy. And L stands for length, and it's a lowercase. W stands for width, and it's a lowercase. They are the parts that are going to help us find the perimeter. Don't change their case, okay? Because it's going to get you in trouble sometimes. So I'm going to guess that if I said to you, I want you to find the perimeter, or find the length of a rectangle. If I give you the perimeter and I give you the width, could you find the length? Do we now know how to do that with an equation? There's how many variables in the perimeter formula? How many variables? P, L, W. If we can substitute in for 2, will we be able to solve for the other? Yes, so let's substitute. Let's put 38 in for P. It says right here, the perimeter is 38. The width is 5, 5L. So 2, well, they were trying to find L. And 2 times our width, which is 5. So we're going to substitute in, we're going to simplify first, and then we're going to go over solving this. So 38, well, not much we can do with that. 2L, not much we can do with that. But what's 2 times 5? 10. Now, are we ready to solve that equation? Actually solve it? Yes. So what would we do first here? Subtract what from both sides? Oh, okay. I thought that's what you were saying, but just making sure. Okay? So we would subtract 10 from both sides. So you didn't even have to think about that. We need to get the L's alone. That's our goal. So we got to get rid of the 10 first. So we now have 28 equal to 2L, right? We got rid of the 10. Now what would be our next step? Divide both sides by 2. Yeah, well, now we would divide both sides by 2 because that's what L is being multiplied by. And we can say our length is 14. Now, we always want to be able to label. Did they say what the 38 and the 5 were measured in? No, so when we don't know, we would just say units. When you find perimeter, do they say units? Are these 14 units? What do you think? Units plus units plus units plus units. What do you have when you keep adding units? Quadruple units? Or are they still just units? They're still just units. So when you have perimeter, this is one thing I find with students that we have a really hard time labeling the difference between perimeter, area, and volume. Perimeter is one-dimensional, units to the first power. Area is second-dimensional, two-dimensional to the second power, units to the second power, units squared. Volume is three-dimensional, units to the third power, units times units times units. Okay, so we have to know how to label correctly. Okay, well, now what if I said to you, instead of actually finding a value for L, what if we don't know the perimeter? What if we don't know the width? What if we still don't know the length? But I want you to solve the formula. So in other words, I want you to solve for L. No numbers involved here. You can't use that 38 anymore. You can't use that 5 anymore. You have to solve that for L. Would we follow the same process, do you think? Why not?
You don't have W.
But still, what's the goal when we're solving? To get the variable by itself. Well, we have to get the L by itself. Can't we still do that? Can't we just still follow the same rules? Can't we just do what we did up above, but without those values being plugged in there instead? What was the first thing we did up above? We subtracted the 2 times 5, which was 10, didn't we? So here, couldn't we just subtract 2W? Because remember, our goal is we want this alone. We want that alone. So we got to first get rid of the 2W. Well, P take away 2W. Are those like terms? No. So here's what we got to do. We're just going to write it horizontally as the subtraction problem that it is. And then these over here took care of each other, so we just have a 2L left. So what would our next move be? What did you do? What was our next move up there? We divided both sides by 2. So we're going to divide both sides by 2. Here's how we're going to divide this side by 2. Just like that, we're going to make one big long fraction bar showing that P minus 2W, that whole expression being divided by 2, and the 2L being divided by 2. Okay, you got to pay really close attention to me here. Over here, these 2's can cancel out because there's only multiplication going on upstairs. So we have our L by itself like we want. But be careful. Over here, these 2's cannot cancel out. They cannot. because we have a subtraction problem going on up there, and we can only cancel out that 2 if it can be canceled out of both parts. Can it be canceled out of both parts? No. So our answer is going to look really crazy, but this is how we're going to have to leave it. We have solved the equation for L. L by itself.
So if you're just trying to solve the formula, like it doesn't have to come out, like that's what
It doesn't have to come out to a number. It's not going to. It can't. Okay? But I also want to show you, remember how I said, we always have to know what's another way we might possibly see our answer in an answer bank. So here's another option we had back at this step when we were dividing by 2, and I want you to do it with me because you always want to be able to see what if the answer I get isn't in the answer bank, is my answer still right? So instead of dividing the whole side by 2, remember the rule for if you divide or multiply, you do it to every piece. So we would give the P its own dividing by 2. We would give the 2W its own dividing by 2. We would give the 2L its dividing by 2. We could have done it that way. Well, if we do it that way, can we do anything here? P over 2. No, we're going to leave it P over 2. Good as that one's going to get. What do you think we can do in that next term? 2W over 2. Cancel. There's no addition or subtraction going on up there upstairs, so we can cancel the 2's this time. And just like we can cancel the 2's over here, we may see the answer like this. So 4. I'll tell you right now, typically, most typically, this is how they're going to show the answer, right here, okay? Most typically, that's the one, but I want you to be aware of that, you know what, if you do it this way, and that isn't the answer in the back of the book, that doesn't mean you're wrong, necessarily. It just means you have named it a little bit differently, because you did everything right. Of course, there are some incorrect ways also. Well, here's how we could check to see if we actually, because all we just did is we renamed the perimeter formula. What was it solved for before we renamed it? What was it solved for? P. It was solved for P. P was by itself, right? So it was solved for P. All we did is take that perimeter formula, solve for P, and we renamed it solve for L. So in reality, if we use either name, we should get the same answer for length. So let's try it and see if we do. Which one of these do you want to use? The red, black circled one or the red circled one? Okay, well you do whatever one you want. We can't see, we're not on consensus, so I'm going to use the black one just because it's right there. 2 times 5 over 2 equals L. Remember, the perimeter is 38, so I'm putting that in for P. The width is 5, so I'm putting that in for W. We already know the length is 14, so if we have a good name here, we should get 14 for L, shouldn't we? So, order of operations says do this multiplication first, so 38 take away 10, divide that by 2. 38 take away 10, what is that? 28. Divided by 2, what's that? 14. We get the same result, don't we? Just from a different name for the perimeter formula for a rectangle. So, for those of us who were trying to solve equations before, kind of like by saying, well, I can just see what the answer is. If I just substitute this, it's going to make the equation true. And not learning the steps to solving it, are you kind of out of luck now if that's the method you were taking? Are you going to know that you should substitute in P minus 2W, that expression divided by 2, that's what you go in for L. Did anyone know that? Kind of doubt it, right? So questions anybody on the front side? This was kind of us just like, exploring or playing around with it and seeing what, we know what to do when we only have one variable? What do we do now when we have more than one variable? Okay, let's go to the back. This is where this practice back here will be most helpful probably on your homework. We're only going to do 3 together. We also have some examples in the book you can study. I have no idea if this is a formula for something. Chances are not. It's probably just an equation with more than one variable. How many variables does it have? Yeah, we can use it up for me. 3. Okay. Well, we're supposed to solve it for x. Okay, that's kind of important. What's it solved for right now? K. K is by itself. Okay, what do you think would be a good first move then? No, what did we do first? Remember, we eventually want this x by itself. So x right now is part of that. We need to get rid of the 5. Think of this as maybe it was 3x minus 5. What if it had been 3x minus 5? Wouldn't we have added 5 first? Add 5 to both sides. Follow the same process. Undo subtraction or addition first. Now we have x, y left. These guys took care of each other. Are k and 5 like terms? No. Okay, we can't put them together, so we just write them like k plus 5. What do we got to do next? Divide by y, yeah, divide by y, because x is being multiplied by y, and I'm going to suggest you write it like I am. Don't just stick your fraction bar there right away, because you're going to be confused when you look at this and try to make sense of it later. That's one way we could do it. Or, remember, Connor in fact said it this way. He says divide everything by y. So xy divided by y, k divided by y, 5 divided by y. You have that option. Either divide the whole side by y, or if there's addition or subtraction, give each term their own division. Okay, either way, what happens here is these y's cancel, because it's multiplication. We end up with x. How do you feel here? Do you think we can do anything with that mess? No, we're going to leave it just like that. We solved it for x, didn't we? We have x by itself. And we followed the legitimate steps. Or we could say, you know what? Oopsie, I just canceled out the wrong thing. I'm going to do that. I want to cancel out the y's. I have x. Can I cancel anything there? K over y? No. Can I cancel anything there? 5 over y? Anything that? Or how are you typically going to see it? You're typically going to see it like this. This is the one that more than likely, that's how we're going to show it. So if you have it ingrained in your brain, how to solve equations that have more than one step of work to do, if you ingrain that in your brain back in lesson 1.4, this should not be a problem. We should be able to just walk through this and say, you know what, I'm feeling confident that I'm doing the right steps. Okay, listen carefully to me for this next problem. And any problem that has a denominator with a variable in it. You do not want variables in a denominator. You just don't want them there. They're just a nuisance there. They're a problem there. So get it out of there. Don't even worry about that. First of all, we need to solve it for y. Well, you can't say, I'm going to just move the x minus 2 somehow and I'll have a y by itself. Y can't be in a denominator when we're done. It has to be upstairs. It cannot be downstairs in a denominator. So no matter what, if you have a fraction involved, we're going to take care of getting rid of that denominator first. So the first thing we're going to do is, let's put that here. Get y out of denominator. That's what this step is going to do. Put this in your notes. You know what we were doing. Y. We're getting y out of denominator. That's our goal here. We're going to take y times both sides. We're going to take y times both sides. So on this side, we need to take it times the x minus 2 over the y. The other side, we need to take it times the z. Because here, if I want to, I can put this over 1, make it into a fraction so it just looks better. Because then if I'm multiplying fractions like we are actually doing there, we know we can cancel one thing up from one thing down. We now have x minus 2 equals, what's y times z? yz. Did we get y out of the denominator? Yeah, that's the goal. We don't want variables down in the denominator. We need to get them out of there. So we do that first, and then say, okay, I need y alone. What am I going to do next? We have to decide what y is, and we need to, what did you say? Divide by z, because y is being multiplied by z. So we need to undo that. Do not do it right away with a fraction bar there. Write it again. And presto, y is by itself. And can we do anything here? X minus 2 over z. Y is by itself. And remember, it's very possible this answer could have shown up like this. We would have given each of them their own z's. So maybe the answer would look like this instead. That's the same thing. Another name with y by itself. Okay, last one. Solve. Capital P, capital V equals little n, capital R, capital T. Uppercase stays uppercase, lowercase stays lowercase, don't switch them around, make sure you can tell what they are. We need n by itself. Anybody think they know what we could do? What do you think we could do in this one? Subtract RT. So in other words, RT is being added to n? It's all multiplication over there, isn't it? Divide by R and then divide by T? Guess what? You can divide by RT right away all together in one step. You can take PV, write it again, Don't just stick a fraction bar there. And now we're going to say, you know what? Since n is being multiplied by the product RT, I can just divide by the product RT. And I do the same thing on the other side. Because there is no addition or subtraction going on upstairs, no addition or subtraction going on downstairs. It's straight multiplication everywhere, so I can do some canceling. R's can cancel. T's can cancel. We have n by itself. Can I do anything with that PV over RT? No way. There's our answer. Now I have to show you something that I'm not going to accept. I cannot count this as done, because I'm going to show you what would happen if, because you were not wrong, some of you, when you said divide by R and then divide by T. You're not wrong. Not at all. So if you wanted to do that, PV equals nRT, you decided that the first thing you were going to do is divide by R, both sides. You would be like, okay, the R's cancel. I did what I needed to do. But then you'd be like, oh, wait a minute, now I've got to divide by T. So the next thing you would do is you would say PV over R. That has to be divided by T. And then my NT has to be divided by T. Well, these guys cancel and presto, N is by itself, but you will never, never, never see an answer anywhere in math, and nor will it ever be accepted when you have a fraction within a fraction. When you have a fraction within a fraction, you cannot leave an answer like that. Eventually, we would have to figure out, okay, well then how do I take this fraction and divide it by t? And eventually we would get it to that. In fact, challenge yourself with that. Somebody, write this down and say, can I get that to equal that? Give yourself that challenge, because I will count this, I'll be like, no, not simplified. This is what I'll say, not simplified. You cannot leave a fraction within a fraction. We want it like this. There's no fractions in our fraction, is there? Okay. Those are the three we're going to do today.